Hello. In this video we will show how to test the requirements specified in Stimulus and how to reuse the requirements and test cases to validate the actual code of an embedded controller. To understand this video, you should have watched two earlier videos. One introduces Stimulus and its operating principles, and the second covered developing functional requirements for a headlight controller. The headlight requirements will be used as the basis for this presentation. Here is the Stimulus model. It has three blocks. The requirements of the headlight controller, which has inputs from the other two blocks. The first provides the ambient light level. The second provides the position of the switch, which can be set to on, off, or auto. To observe the behavior of the system running in automatic mode, we freeze the switch position to auto mode using the force auto test scenario with a simple drag and drop. If you open this scenario, we see the constraint is trivial. Switch is equal to auto. In the automatic mode, the system behavior is interesting when the light intensity crosses the 60 and 70% thresholds. So let's pick a scenario forcing the light to oscillate between 55 and 75%. Let's run the Stimulus simulator for a few dozen steps. We can see that the controller output, headlight, takes the correct value. It is on or off depending on the level of ambient light. The requirements seem correct. We are indeed getting the expected behavior. In the same way, we could describe other scenarios and, with a simple drag and drop, apply them to our requirements, then simulate again to ensure that they are correct. We have now developed requirements and debug them. Let's move on to see how Stimulus will help us validate the real code that implements the specified system. How can it help us to find interesting test cases which we might not have thought about? We will replace the requirements with the real controller by dragging and dropping the DLL wrapper, which contains the link to the DLL controller, declared in the external block DLL controller. Stimulus will help us validate that the actual controller behaves as specified. For this, we will use the requirements as observers. If the requirements are violated during the simulation, Stimulus will report it. Here is a package, rec all observers, containing all the Stimulus observers to check that the code meets the requirements. To use them while testing the code, simply drag and drop. We will now test the code, first with the same scenarios used during the requirements validation. Let's run the simulation for a few sets, each of 20 steps. The observers are green, so the code seems to meet the requirements. Since we are now dealing with the real code, we can test further. This time we will give more freedom to the test scenarios generated by Stimulus, so as to shake the code more strongly. To do this, close the simulator and drag and drop the guided random scenario for the ambient light generation and the random scenario for the switch. In the ambient light scenario, Stimulus will consider that light is between 0 and 100%. Light can also vary by 10% at each step. The switch scenario defines no constraints, so the switch can change value at any time. Let's start testing with a few sets of 20 steps. At first, the observers are green. As we continue, the observers turn red. When we open the observers, we can see that the code has violated the requirement 3.1. If we ask Stimulus to show this observer in the simulation window, we can see that it changes its state. We can zoom in to see precisely what has happened. The last step before the code diverged from the specified behavior, the situation was the headlights are off, the switch is off, the ambient light is below 60%. At the time of the error, the headlights are off, the switch is auto, the ambient light is between 60 and 70%. But according to requirement 3.1, in this situation, the headlights should be on. In fact, the bug appears if, simultaneously, the switch changes from off to auto and the light is between 60 and 70%. Here, Stimulus has found us a particular test case which can be recorded via the export to CSV function. What did we see in this second sequence? The first simulation with the real code used a rather obvious use case that we would typically have thought of. This use case was used to debug and validate the requirements we reused on the code, and it could be part of the list of test cases. In the second simulation, using the real code, Stimulus used a less constrained scenario, therefore had a lot more freedom to test the code and explore less probable scenarios, which we would probably not have thought of given the high combination of cases. In other words, Stimulus can easily test the code to its limits, generate and use less obvious test cases, and therefore find bugs in the code that could have been missed. To do all this, it only needed a few drag and drops to change the test scenarios to be applied to the requirements or to the actual code, to add observers used as test indicators, and to reuse the requirements modelled previously. Using Stimulus is simple and very effective. This video will not answer all your questions. Please contact ArgoSim, as we have much more to share with you on requirement validation and simulation.